Hello, my name is Min-seok Kim, and I'm gonna present the paper Leading by Example and Signaling in Voluntary Contribution Games, an Experimental Study by Ian Porters, Martin Septon, Lisa Vesselon, published in Economic Theory 2007. Before we get to the main topic, let's imagine a situation that the air in the whole city is covered with fine dust. It's hard to see further and it has a bad effect on your health too. Obviously this is inconvenient for people. So one opinion is suggested, let's plant a tree, then we could overcome the environmental problem. But one thing, it costs a certain amount of money. Suppose it's $100 for each. Would you participate in or not? Well, it depends on how serious the situation is. Maybe not many people would not participate in because of free rider problem. They might think they can fully benefit from the public goods without contributing. Then plus another condition. What if one person takes the lead and contribute first? Does the presence of leader increase voluntary contribution to public goods? For that, there are lots of field experiments supporting the argument that the behavior of lead by example may increase total contributions to public goods, such as Allen in 1998 or Westerland in 2003. Then we have one question here. What is the intrinsic power of this leadership? Is it because the leader is a special person? There are several possible explanations, like signaling, reciprocity, and inequality aversion. In this presentation, we will explore why the ability to lead by example increases contribution to public goods, and it is the main idea of this paper. Now look at the model of leading by example. The experiment is based on a simple voluntary game. There are two players, leader and follower, and each player decides whether to contribute or not to a group activity. The payoff function is like this, where m is the private return rate. It could be 0, 0.75, or 1.5. In the sense of joint payoff maximization, we can easily find that neither player contributes if m is 0, and both players contribute if m is 0.75 or 1.5. But does the player really choose to contribute? Suppose both players observe m before making their choices, and this is common knowledge. In this full information environment, suppose that the subjects make their choice simultaneously when m is 0.75. If the leader and the follower both contribute, they can get the highest total output. However, at that point, each player can get 0.25 more if he or she chooses not to contribute only. That means they both will choose not to contribute. Then this option will be the Nash equilibrium. Thus, in conclusion, both players contribute if m is 1.5 and neither player contributes if m is 0 or 0.75. Now consider the situation where only the leader observes m. So the asymmetric information. Because the expected value of m is 0.75, as we found above, follower will not contribute at any chance. But leader chooses to contribute only if m is 1.5. Leader can get more output when he contributes regardless of the follower's decision. At the asymmetric information environment plus another condition, the leader moves first and then the follower chooses. Through the mechanism, the follower can draw an inference about m from the leader's decision. Assume m is 0.75. If they choose simultaneously, followers do not contribute, and leaders expect that result, then they also choose not to contribute. But with the sequential move, the leader could induce the follower by choosing to contribute. It is like delivering information that I know what M is, and with this M, contribution is the best choice. This is what we call signaling. Thus, at the end, the follower mimics the leader's choice. Both players choose to contribute. This table is the summary of what I said, so we can find that only with the condition of asymmetric information environment and a sequential move, both players could achieve the total payoff maximization. But some people might think that the result is because of non-pecuniary factors such as reciprocity or inequality of origin. It is like the follower considers a contribution as a kind act, so the follower contributes when the leader contributes to repay his kindness. Or players are sufficiently averse to advantageous inequality position, so the follower just contributes not to make a difference from the leader's choice. What is the right explanation? Through the experiment process, we could find the answer. They examined two-person simultaneous and sequential contribution games under both asymmetric and full information conditions. Thus, the experiment consisted of 4 different treatments. For each treatment, they ran 4 sessions, and that each session, again, consisted of 18 rounds. With one session, there were 12 subjects, so total 192 subjects. Subjects were undergraduate students at the University of Nottingham. For each round, they randomly and anonymously assigned to a treatment with a given role of leader or follower. Subjects participated in only one session, no one played with their partner twice in a row, and no pair of subjects would be matched more than 3 times. At the end of each round, subjects were informed of their choices and final payoffs in their game. Now during the game, 2 players were asked to choose the action A or B. Choosing A, you can certainly get 40 pence, and choosing B, you can get 0, 30, or 60 pence, all equally likely, and it could be double when your partner chooses B. So it can be summarized as exactly 4 times of the simple model, what we saw. To be simple, by choosing A you contribute, and choosing B is the opposite. The game is over, and let's look at the result. First, in the asymmetric information, that means only the subject at the leader position observes the size of M. For both sequential and simultaneous treatment, leaders almost never contribute when M is 0 and contribute when M is 1.5, regardless of the follower's decision. On the other hand, followers do not have the information about M. For the followers, each round seems to be equal game. So the contribution rate is almost the same in simultaneous treatment, but what should we focus on is this part. There was a super change at the leader contribution rate when M is 0.75, 15% to 75%. In the sequential treatment, followers mimic a contribution of the leader by 80.6% and not to contribute by 92.2%. Leader anticipates this response, then they decide to contribute when M is 0.75. It is the big difference compared to the simultaneous one. Just by observing what leaders choose, followers decide to change their mind. First, leaders' contribution rate going up, and we can see the followers' contribution rate jumped over the simultaneous treatment. And this is the graph. We know that with the sequential move, subjects behave more efficiently. That is, they choose not to contribute when M is 0 and contribute when M is 0.75 or 1.5. But there is the question, is this result really because of signaling? There are other non-pecuniary factors that can affect the result. It is like maybe the follower might think, oh, I see the leader choose the contribution, and it's a kind act for me, so I'm gonna contribute too. Then look at the other treatment result. Now, we look at the results in full information. Both the leader and the follower knows what M is. They are informed of the consequences of their choices in advance. Similarly, regardless of the treatment style, subjects generally contribute when M is 1.5 and don't contribute when M is 0 for their own payoff maximizing. It is a matter of course. Then think about when M is 0.75. With Nash equilibrium above, we can simply predict that contribution rate is low when M is 0.75 if they are in the simultaneous environment. Did something change with sequential treatment? To answer that question, we need to focus on the red box. First subject, when M is 0.75, they tend to contribute more than the simultaneous one. On the contrary, the second subject, they tend to less contribute than the simultaneous one. What does this suggest? If social preferences like reciprocity are the main explanation of the difference between the sequential and simultaneous treatments, subjects may mimic the contribution by the leader, but they didn't. Lead by example caused a decrease in follower contribution, 27% to 9%, while there was an increase in leader contribution. Thus, in the full information environment, lead by example does not improve group outcomes. That means it is unlikely that other explanations drive the effective outcomes we found in the asymmetry information treatment. In conclusion, the most important thing of the paper is this. When an uninformed follower can observe the choice of informed leader, he or she tends to copy the leader's decision, and it is called signaling. So signaling plays an important role in explaining the success of leadership in the asymmetric information environment. And finally, we could observe the evidence of reciprocity because the contribution rate of leader increased, but it does not lead to an increase in total contributions. The size of decrease of the follower was way bigger than the increase. So, it is the final page of the presentation. If you have any questions, please let me know. Thank you for listening.